Hello guys, today we are going to talk about how to use PID compact controller in TIA Portal. I have TIA Portal version 15 installed on my computer. It's pretty heavy program, even though I have good hardware configuration. You can see we still have this time lags between operations. So let's switch to the project view and add new device. Controllers, let's say this one, okay. Now, as we have added the controller itself, we have program blocks. Let's add another one. Cyclic interrupt. Okay. Since we are going to build the control system, we are using cyclic interrupt or B30 block, which has time between its operating of 100 milliseconds. So first things first, let's build our control object model. For this purpose I'm going to use the library let's see. Okay, let's open LSeam library. This LSeam library can be downloaded from the Siemens website. It has all the necessary dynamic links for building your control systems and models and so on and so forth. For example, if you want to build some correctional link, okay, we go to master copies, and first we are going to add that time block. Not this one. Okay. And we are going to add a periodic link block, so we will have control object model of the first order. And for the controller, we go to the PID control, compact PID, and add it in the second network. Okay. So the input of our control object model will be signal from controller, Output from the object will be process value. Output from the PID controller is going to the control object model. Okay, let's say delay cycles. So we have to go to the data block of this LSim logging link. So let's say I want dead time of 1 second. So it will be 10 cycles for 1 second delay. Time constant for our periodic link will be 2 seconds. Gain K1. Cycle 100 milliseconds. Okay. Initial set point. So let's define our tags. So here we can configure our PID compact controller in TIA Porta. Here we can switch between the different types of the controlled variables, but I will leave general in just % mode. We are not using peripheral inputs, outputs, so we are using just the default ones. So I will leave here everything by the default except these PID controller parameters. I know that for these control object parameters I need these parameters of my PID controller. Let's leave it PI controller. Okay. Sampling time. Yeah, that's nice. Let's save our project. And try to compile it. Okay, seems to be no errors. Sorry about that. What the fuck? Okay, I will start PLC simulator. You see, that's what I'm talking about. I have pretty decent hardware configuration. and still I have to wait this long time to just create some new project or other operations. It's very strange, very strange. Okay, I have S7 1500. Let's power it on. Okay guys, we have to select this option. So we have to support simulation during block compilation, otherwise it will not be simulated in our LSeam. So let's recompile it and download. So it has found this simulator. Okay, let's load it. Software. Okay, load. Error downloading. Why? What has happened? Okay, let's restart it. Okay, now everything seems to be okay. Let's start the module. Go online. Let's put monitoring mode on. Sorry about that. Display format, network, floating point. Display format, network, floating point. Okay. So now we have to go to the PID compact menu, interactive one. Let's start measuring. So we can see the set point value, input, output, manual mode. Okay. Okay, now we can see our transient process. Sorry about that. Okay, let's change this variable. Something is terribly wrong. Okay. At last. So the problem was that in the settings menu it was set for peripheral inputs and outputs, and I have connected not the peripheral but the default input and output. So it's very interactive settings for this PID compact controller, because you can see the trends in its menu. So let's say we change the set point. And here we can see how our variables, the process value, the controller output and the set point have changed. We have pretty decent transient processors, but if it's not, you can use the fine-tuning of your PID controller, and the system will calculate the optimal values of your PID controller. Let's change the set point again. So as you can see, everything is working pretty decent. And you don't even have to create the simple SCADA trends for this. You can utilize the trends that was implemented in the PID compact controller itself. So I hope this information has been somewhat of use for you guys, and I'll see you next time.